Okay, so now let's look at the quotient rule. Now, the quotient rule can be applied if you have two differentiable functions, u and v. Now, v cannot equal 0, which makes sense because if v was equal to 0, it would be undefined. So let's say you do have a quotient and you want to find the derivative. Now, this might look confusing, but don't worry, we got this. It's just a rule. So the derivative of u over v would be v, the denominator, multiplied by the derivative of u, which is the numerator, minus u, which is the numerator, times the derivative of the denominator, which is v, all over v squared, which is the denominator. Phew! But we will get this. So another way to write this is you have v, which is the denominator, times the derivative of u, minus u, which is the numerator, times the derivative of v, which is the denominator, all over v squared. Now, because I love you so much, I'm going to make a fool of myself right now. And because I think that this will help you to retain it. So when I was in my calculus workshop, we learned a little yodel to help students remember this. And our yodel is going to use the terms high, which represents numerator, and low, which represents denominator. So bear with me as I yodel. Okay, here we go. So if you want to find the derivative in respect to x of high over low, so you go, whoa, see, maybe it's meant to be. Maybe I shouldn't yodel. Where did it go? Oh, there it is. Okay, here we go. So what you do is you go low, d high, minus high, d low, all over the square of what's below. Okay, now you're like, what, Kleiber? Square of what's below. Now, at first, this looks like gibberish, but you'll get the rhythm. Here we go. Let's try this again. So it's low, d high, minus high, d low, all over the square of what's below. So d means derivative, right? Low, d high, minus high, d low, all over the square of what's below. I know. You love it, don't you? Okay, let's do an example. Here we go. So let's say we're given this function of x squared minus 1. So the numerator is x squared minus 1 all over x squared plus 1. So the denominator is x squared plus 1. Okay, so what we're going to do is I'm going to yodel a little bit. Low, which is x squared plus 1. D high, so D means derivative. High is the numerator. And no, I'm not high. So low, d high minus high, which is the numerator. D low, derivative of the denominator, all over the square of what's below. Really, the tricky part is just making sure you get the order correct, and that's like anything with division. Low d high minus high d low all over the square of what's below. So that's your calculus. Now the rest of it is just some well, we do have to take a derivative of the power, I guess. So we have x squared plus 1 times 2x minus x squared minus 1 times 2x all over the quantity x squared plus 1 squared. Now it's just some algebra, and we just have to combine like terms in the numerator. We can leave the denominator as it is because nothing's really simplifying there. So we get 2x cubed plus 2x minus 2x cubed minus 2x. Be careful with that negative and distributing it to the whole binomial. It's where a lot of common mistakes happen. All over x squared plus 1 squared. So we see the 2x cubes will reduce out. So 2x plus 2x minus a negative is 4x. There we go, folks. 4x over x squared plus 1 squared. So it's not hard, just a little bit tedious.